This lesson is on similar triangles. Today we did a lab that involved measuring angles and looking at the sides of triangles to see if they were similar. Here we have a problem with two triangles. Now we cannot assume that these two are similar just because they look the same. First, let's look at the sides. We want to set up a ratio. So we have triangle A, B, C, and we want to look at whether or not it's similar to X, Y, Z. So let's look at the side AB. So we have AB is equal to 10, and this is how we would write line segment AB with the line over it. And it is referring to the part of the triangle that I've underlined in orange. Now we want to put this over the corresponding side in the similar triangle. Well, what we presume to be the similar triangle, which would be XY. At this point, we can pick any of the other sides on our first triangle to compare to the second to see if they are similar. I'm going to choose CB. So line segment CB is 8. Since we did the first triangle on this row, we're going to keep it on that row. And then finally, we're looking at the corresponding side on the second triangle, which would be ZY. So that would go over 10. So these ratios should be equivalent if they are similar. You can do a couple of things here. You can cross multiply, which we've practiced in class. So we would say, I was accidentally on eraser when I was trying to show you that last problem. So cross multiply, let's try this again. So we know that we do 10 times 10. I'm going to go ahead and write this out. So I've shown you how we would cross multiply. 10 times 10 is equal to 8 times 14. We know 10 times 10 is 100. I did some quick math and found that 14 times 8 is 112. These are therefore not equal. So that means that these are not similar. Let's try another problem. We're going to look at this problem. Now we can compare sides here, but I want to review how to use a protractor. So the first step that we use is to make sure that our protractor, the center of it, matches our vertex. So vertex is the corner of the figure. It's where two sides meet. The problem with the protractor that I have is I've had to use a picture, so I'm going to talk you through how to use it, but realize that I'm not able to do as much as possibly you are here. So we're going to take this protractor, and I would just move it. You would want to move it where, again, that corner matches the vertex, or the hole in the center matches the vertex. And mine is not transparent, as I mentioned, so I'm just guessing here. But I am going to make it small enough to show you a couple of things. So we want to make sure that our protractor is lined up where one of the sides is going through this baseline, or what I call a baseline. It goes through this 0. Now realize that there's a 0 there and a 180. We're going to start at 0, and we're going to count all the way up. So we're on the inside numbers. We're going to count all the way up until we get to where the second line passes through. So if you look at this, we're looking at 10, 20, 30, 40, 50, 60, 70. So we're saying this is 70 degrees. Now this might not be super accurate because of the way that I had to blow up the figure, but and the fact that I don't have the protractor being transparent like yours would be. But this is as close as we can get it. So it is important here to notice that our answer is not 110. There's a couple of reasons why. We know this angle is acute. So there's no way that it could be more than 90 degrees, because acute means it would be less. Also, you have to make sure that you're counting on the bottom if you're measuring an angle that's going towards the right. But just always start at 0, and your answer should pop up when you get to the second side. Now I've lined this one up, and you can tell that this is lined up with 0 here, and then it also is 70 degrees. I'm going to try my best to show you that we could do the same thing if we lined it up with the smaller triangle. Make sure that this is on the 0, really as close as we can. And you can also tell that this side this side would be 70, this angle that we're looking at. And if we lined up the other direction, making sure to stay on 0, trying to get that vertex in the center, you would see again that that this would line up with the 70-degree mark here. So by showing that our corresponding angles are both equivalent, we can also call this, or we can call this, a similar triangle.